Hello everybody and welcome to another video here at Sage of the Six Maths. Today I'm going to be showing another graphing example. This one is going to be of a natural log function. These ones can be pretty tricky sometimes, so let's try to graph it using our derivatives. Okay, so here we have y equals the natural log of x squared over x plus 1. I just have a graph of what the natural log of x looks like, okay, to remind us sort of the domain and sort of just the general shape and what it looks like. So first thing we want to do is we want to find out the intercepts, okay? While we're thinking about the intercepts, we also need to start thinking about the domain restrictions on this function, okay? So we know that the natural log of, when we take the natural log of anything, we can't take the natural log of 0, and we can't take the natural log of any negative number, because it just doesn't exist on this side of the graph. So what does that mean for our example? Well, that means that this part inside of our the thing that we're taking the natural log of, cannot be equal to 0, right? So if I set that part equal to 0, and we solve, we're going to take x plus 1, move it up to the top, multiply by 0, that's just going to be 0. So we're going to have 0 equals x squared, and x equals 0. Okay, so right away we see that x cannot equal 0. If x is equal to 0, it makes this whole thing 0. Can't take the natural log of 0, okay? Another thing we need to be aware of is the thing we're taking the natural log of, or the inside function, that function also has a spot where it doesn't exist. See, if I plug in -1 for x, that's going to make my denominator equal to 0. And I can't divide by a negative number. So right away I know that my x cannot equal 0, and my x cannot equal -1, because that's going to make my inside function non-existent, okay? Another thing we know from our natural log is that we can't take the natural log of negative numbers, like we said before, right? So this thing inside cannot be negative. So if I put in a -2 here, if I go -2 plus 1, that's going to be -1. I'm going to be dividing a positive number by a negative number. That's going to give me a negative. If I put in a -3, same thing, -4, -5, all the way to -infinity, okay? It does not exist in between -infinity and -1. I have nothing there, so I cannot take the natural log of a negative number, okay? So right away we have several restrictions on our domain. After this, anything in between 0 and anything in between -1 and 0, we have something there, and everything in the positives greater than 0, it looks like we have something there. So we can take the natural log of any positive number, right? So it's going to be something. Now, looking at our intercepts, we want to try and find an x-intercept, so we're going to set y equal to 0. Well, in order to make y equal 0, we know that the natural log of 1 is equal to 0. So I have to try and make this inside part here equal to 1 and try and solve, okay? So if I go 1 is equal to x squared over x plus 1, I'm going to multiply my x plus 1 by the 1 and move it up here, right? Is equal to x squared. And then I'm going to move everything back over to the other side. So I have 0 equals x squared minus x minus 1. I have to try and solve this quadratic here. In order to solve this quadratic, you need to use the quadratic formula, our best friend, of course. So the quadratic formula, we have -b, right? So that's going to be -1, which is going to be +1. Then we have our plus minus, and inside the square root we have b squared, which is negative 1 squared, which is just 1, minus 4ac, right? So 4 multiplied by 1 multiplied by negative 1, that's going to be negative 4, right? So minus negative 4, that's going to turn into a plus 4. And here we have over 2a, which is 2 times 1, which is just 2. So right away we see one plus root 5 over 2 and 1 minus root 5 over 2 are going to be our our x-intercepts, okay, when y is equal to 0. So I'm going to extract those points out here, and I'm going to write them down. I'm just going to give myself a little bit more room here. I'm going to erase this because we're going to have a lot more stuff to write down. I'm just going to erase all this here. And I'm going to put my intercepts here. So I have 1 plus root 5. Oh, sorry, I'm going to start with the minus here. 1 minus root 5 over 2 and 0. And then we have 1 plus root 5 over 2 and 0. We're going to erase this part here. Oh, got it right here. Okay. Now, looking at the intervals of increase and decrease, we need to find the first derivative of our function up here, okay? Well, in order to take the first derivative, I'm going to use my rules of logarithms to separate this function out, because when I'm taking the natural log of x squared over x plus 1, I can separate that into natural log of x squared minus natural log of x plus 1. Remembering our rules, right? So I'm going to do that first. So here I have natural log of x squared minus the natural log of x plus 1. Well, here, another rule of log is I can take this 2, I can move it over to the front, right? So it's no longer going to be an exponent on the x, it's going to be on the front. Now this is much easier to differentiate, okay? So we're going to go y prime is equal to, the 2 is just going to come along for the ride because it's the constant at the front. Then we have over x, because the derivative of natural log of x is 1 over x. Then we have minus, we're going to go 1 over x plus 1, and we're going to multiply by the derivative of the inside function, which is just 1. So I don't need to write it down, it's just 1 over x plus 1. Now, setting this equal to 0, well, we have 0 equals 2 over x minus 1 over x plus 1. Moving my 1 over x plus 1 over to the other side, I have 1 over x plus 1 is equal to 2 over x, right? Then we do cross multiplication, and we have x is equal to 2x plus 1. Then we have x equals 2x plus 2, expanding that 2 into my bracket. Now I am going to move my 2 over to the other side and my x over to the right hand side. So I'm going to have negative 2 equals 2x minus x, and negative 2 equals x. There we go. X is equal to negative 2. So what does that mean for our original function? This is where the derivative of our tangent line is 0, so we have either a max or a min at this point. However, looking over here at our domain restrictions, our domain for this function doesn't exist between negative infinity and negative 1, and we just got a negative 2. So that doesn't help us at all, okay? We don't have any max or mins in this function. What's going on is our function is either always going to be increasing or always going to be decreasing. So you can plug in any negative number that exists within the domain of our original function into the derivative and figure out whether it's always increasing or always decreasing, right? So if I just plug in 1, let's say, I'm going to plug in 1 up here, okay? So I'm going to go 2 over 1 minus 1 over, that's going to be 1 plus 1, which is 2, right? So we're going to have 2 minus 2 minus a half, which is going to be, it's going to give us a positive number. Yeah, that's going to be positive, right? Okay. Now, because we plugged in a number, we have something in our function that is in between these points, the 0 and negative 1. Here I plugged in a point that was greater than 0 into our derivative to see what's going on. When it's greater than 0, it's always increasing, okay? So when I do my number line here for this, we want to go with our 0 and we want to go with negative 1 here. Because they don't exist over there, but they exist in between. They don't exist on this side. I know that, so I don't have to worry about anything lower than negative 1, but I do have to worry about this. So this side, when it's greater than 0, it's increasing. When it's in between negative 1 and 0, well, let's see, what if we plug in negative a half, let's say, into that function, right? So we have 2 over, this is going to be 1 over 2 here, minus, this is going to be 1 over 2 plus 2 over 2, that's going to be 3 over 2, right? To change this, we're going to be, that's 2 divided by a half, which is the same as saying 2 times 2, right? So that's going to be 4. And here we have 1 divided by 3 over 2, which is the same as saying 1 multiplied by 2 over 3. So that's going to be minus 2 over 3. Yep. So it should be negative here. Positive. This number should be negative. We're gonna figure this out in a little bit, but this part here I know should be negative. I did this question earlier, so we'll figure out what's going on here. Okay. Oh, I know what's going on. We did positive 1/2. Should be negative, right? So this part down here is going to be negative 1/2 plus 1. So that's going to be negative 1 over 2 plus 2 over 2, which is going to be positive 1 over 2. Right? And here, instead of having 3 over 2, we're going to have 1 over 2, which is the same as 1 times 2, which is going to be 2. So it's going to be negative 4 minus 2, which is going to be negative. There we go. Those pesky positives and negatives, always getting people. All right. So now we're going to take the second derivative to find out our concavity intervals here, okay? So I'm going to use this form over here. So we got y double prime is going to be, first what I'm going to do actually is I'm going to set it up like this. I'm going to go 2, I'm going to go x to the negative 1 minus moving the x plus 1 onto the top and putting a negative 1 exponent on the top. That's going to make it easier for us to differentiate once again here, okay? Moving the negative 1 down using our power rule, that's going to be negative 2, and this is going to be x to the negative 2, so I can go ahead and put it on the bottom as an x squared, right? Here I have minus, the negative 1 is going to move to the front, so that's actually going to become a plus. It's going to be 1, right? So I'm not going to write it down. And then here it's going to be x plus 1 to the negative 2 exponent. So I'm actually going to have x plus 1 squared on the bottom. Setting this equal to 0, we're going to do the same thing we did earlier. We have 0 equals negative 2 over x squared plus 1 over x plus 1 squared. We're going to move this one over to the other side. So we have 2 over x squared is equal to 1 over x plus 1 squared. Okay? Now we're going to, once again, we're going to cross multiply. We're going to move it up here. And we're going to have 2 multiplied by x plus 1 squared is equal to x squared. Now I'm going to FOIL this out, and I'm going to multiply everything by 2. So this FOILed is actually just x squared plus 2x plus 1. So if I multiply everything in here by 2, I'm going to have 2x squared plus 4x plus 2. And that is equal to x squared. Now I go 2x squared, if I move this x squared over to the other side, it's going to be minus x squared. So 2x squared minus 1x squared is just going to be 1x squared. So I have x squared plus 4x plus 2 is equal to 0. Once again, we need to use quadratic formula to solve this. So I'm going to move that over here. We have negative b, so negative 4, plus minus the square root of b squared, which is 16, minus 4ac, so 4 times 1 is 4, times 2 is 8, so that's going to be 16 minus 8 divided by 2a, which is just 2 times 1, which is 2. Moving on down here, we have negative 4 plus minus, this is going to be the square root of 8, and if you guys remember, the square root of 8 can be rewritten as root 4 multiplied by root 2. Well, the square root of 4 is just 2, so this is 2 root 2, okay? So I have 2 square root 2 over 2. Now I'm going to factor out a 2 from the top side. If I factor out a 2 from the top side, my negative 4 is going to become a 2, my 2 is going to become a 1, and my 2 on the bottom, the denominator, is going to get canceled out with my 2 that I just factored out from the top. So what I'm going to have here is something that looks like this. Negative 2 plus minus root 2. These are our intervals of concavity. Or these are the points where our second derivative is going to be 0. That means these are our inflection points, where we change from concave up to concave down, or vice versa. Okay? So, if you want to do a number line for that, this is my 0 here, so I'm going to go, I'm just going to make arbitrary points here. This is going to be negative 2 minus root 2, and this is going to be negative 2, oh, excuse me, my 0 is actually going to be over here. Both of these values are, yeah, both of these values are going to be negative. Okay, this is going to be negative 2 plus root 2, right? And we have values here in between these two, and then when it's greater than that one, okay? We're going to plug some of these values into our second derivative to see what we get, okay? Whether it's positive or negative. That way we'll know whether we're concave up or concave down. Negative 2 minus root 2. Root 2 is, let's see, I believe it's 1.4. So this is going to be negative 3.41. So I'm just going to go ahead and put in negative 4, okay? I put in negative 4 into my second derivative down here, right? Negative 4, so that's going to be negative 2 over 16, right? So that's going to be negative 1 over 8. And that's going to be plus 1 over negative 4 plus 1, that's going to be negative 3 squared, that's 1 over 9. Well, negative 1 over 8 is greater than 1 over 9, so I know that this is going to be a negative number. So on this side, we're negative. Where's mine? There we go. Plugging in something in between negative, that was like 3.4, and this is negative 0.6. So I'm going to go ahead and plug in negative 1. I'm not going to plug in negative 1 because we don't exist at negative 1. I need to plug in something else. I need to plug in like negative, let's see here, get an actual value here. plus root 2. Negative 0.58. So you can plug in 2 over 3, negative 2 over 3, okay? So we'll go negative 2, divided by negative 2 over 3 squared. Well, 2 over 3 squared is going to be 2 over 3 multiplied by 2 over 3, and that's just going to be 4 over 9, okay? So we're going to go 4 over 9, and we're going to go plus 1 over, and that's going to be 2 over 3 plus 1 plus 3 over 3, so we're going to have 5 over 3 on the bottom over here. Okay, and that's going to be negative 18 over 4 plus, it's going to be 3 over 5. Well, this is going to be negative 9 over 2 plus 3 over 5. This is also going to be negative, okay, because negative 9 over 2 is greater than positive 5 over 3. This is also going to be negative, so we have negative between here and here. On this side, I can plug in, oh, I wish I could plug in 0, but I can't. I'm actually just going to plug in 1. Plug in 1, we have negative 2 over here plus 1 over 4. Negative 2 plus 1 over 4, that's still going to give us a negative number. So we're negative all the way through. Concave down the whole way. Okay? Alright, so now I'm going to attempt to draw my graph here. I only have a little bit of space here, so I'm just going to get rid of some of this information here. Oh, before I draw it, I need limits. Okay? So we're going to need the limit as x approaches, I need 0 from the right, I need 0 from the left, I need the limit as x approaches negative 1, once again from the left and the right, and I'm going to do the limit as x approaches positive infinity as well, because I don't need to worry about negative infinity because I know my domain doesn't exist at negative infinity, so I don't care about that. Now, really quickly here from the left side of negative 1, well, we know we don't exist here, so I actually don't need this either. Okay? We just need the remaining 4 here. The limit as x approaches 0 from the right-hand side. Well, 0 from the right-hand side, you can plug in like 0.1. What's going to happen is you're going to see that it goes towards negative infinity. Okay? It's going to be negative infinity on this side. Just plug in 0.1 or 0.01. You'll see it goes down to negative infinity. Here, approaching 0 from the left side, you'll see that you'll also have negative infinity. Negative 1 from the right-hand side. You're going to have positive infinity. And here the limit as f of x approaches infinity, well, if I take the natural log of infinity, I'm going to be going towards positive infinity. Just looking at this graph as well, right? Okay, so now I'm going to attempt to draw it in this small little space I have here, but that's okay, that should be enough. Hope you guys can see it. Okay, so I'm going to go, this is negative 1, this is negative 2, this is going to be 1 up here, this is going to be negative 1, I have 1 I'm going to have 2 over here. Okay? All right, so here at x cannot equal 0 and x cannot equal -1, so I have asymptotes there. And 1 right at 0. Okay? X approaches -1 from the right-hand side is going to be positive infinity. So I know I'm coming down from here. And here, as x approaches 0 from the left-hand side, I have negative infinity. So I'm going down through here. So I'm going to have a curve that's probably going to come down like this. And we're going to need to use our x-intercept over here. 1 minus root 5, right? Yeah, so that's going to be 1 minus 2.23. 2.23. It's going to be divided by 2. That's going to be negative 0.6. 0.6 is going to be somewhere over here. So we're crossing over there. And positive, the one on the positive side there is going to be 1 plus root 5 divided by 2. That's 1.6. So it's going to be somewhere over here that we cross, okay? So here we have a curve coming down like this. Here on this side, we also are coming up from negative infinity. X approaches 0. As x approaches 0 from the right-hand side, we have negative infinity. So we're coming up from here, and we're crossing over here at 1.6. Right? So we're going to cross that point, and we're going to go towards positive infinity. Okay? So that's what it looks like there. Whew, sorry about that. A bit of a long one here, a lot of information, but I hope I covered everything. Everything looks to be in check here. But these ones are pretty tricky, so just take your time, be careful, and really sort of use your intuition and analyze all of the information that you're getting from these derivatives. Okay, hope you enjoyed it. Have a good one.